All right, number one in section 4.5, the first one wants us to determine the domain of the rational function. So we are given function of x is equal to x squared over 5 minus x. So to find the domain, all we do is focus on the denominator. And I'm going to say D for domain. The most important thing is we cannot divide by 0, so that is a fact you have to remember. So I'm going to say 5 minus x cannot be equal to 0. Start there. And we're going to solve for x. So I like to deal with positives. Usually we move the number over. This time I'll move the x over. It'll be the same result. If I add x to both sides, this will cancel out to 0, so I'll be left with 5 cannot be equal to x, or x cannot be equal to 5. So basically that says if the bottom is 5, we get a 0 in the denominator, and that will cause a problem. So when you're listing your domain, think about this as a number line. So we have negative infinity to positive infinity, which represents all real numbers. And imagine removing the number 5. So let's say that this is 0. Here's the number 5. Okay, we're going to be removing that number. So it like make a hole. Okay, if you're driving down the road and there was like a hole, there'd be like a gap here. We would be removing this point. So we get two sections. We get domain, if we want to write it in interval notation, will be negative infinity up to positive 5. And then we'll have to do like a bridge or something to get across, and then we will pick back up on the other side of 5 to positive infinity. So you can do it one of two ways. You can say domain, and I'll just write it. We like to write the variable on the left. X is not equal to 5. Okay, this is one way it could be written, and this is another way that it could be written. But in this case, we just cannot use the number 5. So they want it in interval notation. So this number line method that I used. Make a negative to 5. To 5. Positive infinity. I'm using keyboard shortcuts. I use the backslash and INF to pull up infinity, but you can have it at the bottom and use the clicks. You also have the union symbol. I like using the type setting. It kind of helps me not have to grab the mouse. Number 2, same thing. We're going to find the domain. This time it looks like we need to factor. So we have a function of f. We have x squared minus 28. Okay, so we're going to factor denominator 1 and 28. So I'm multiplying leading coefficient times 28. Our constant term, I'm going to write the factors of 28, 1 and 28. 2 and 14, 4 and 7. I want factors that when I subtract will give me 3, and that will be 4 and 7, so that tells me it does factor. So just focusing on the bottom again, we get x, separating the x squared, 4 and 7. This is positive, that's my bigger number, so 7. And then the signs will be different, so I need to subtract. So this is the bottom factor. Again, you can see there's no common factors here, but again, I'm only focusing on setting these equal to 0. So my domain is that the bottom cannot be equal to 0. So when you have it in factor form, the only way that this is going to equal to 0 if this one is 0 or this one, or they both could be 0. So let's figure out what those numbers are. Here we would set x minus 4 not equal to 0. We would add 4 and we get x cannot be equal to 4, And with this one, x plus 7 cannot be equal to 0. We would have to subtract 7, and that would give us x cannot be equal to negative 7. So these two numbers would make the denominator 0. Again, we want this in interval notation, so I think about a number line. And negative 7 would be on this side, and 4 would be on over here, and let's say 0 somewhere in the middle. We would get rid of this number and get rid of this number, so it breaks our number line into 3 sections. So we go from negative infinity up to negative 7, and then we have to break that apart. We have negative 7 to positive 4, and then we have from positive 4 to infinity. So the domain will be broken into 3 pieces in this case. Say negative infinity, negative 7. And then we'll add a union, wrong button, add a union. And we'll have negative 7 to 4. And then last part, we have 4 to infinity.